Welcome to Manufacta. We often take for granted the things that keep us safe. Walls, fences, and doors are obvious barriers, but what about an invisible shield? Bulletproof glass is one of those marvels of engineering that often goes unnoticed, silently protecting people in high-risk situations. It's easy to walk by a bank teller window or a security checkpoint and not give it a second thought. But behind that seemingly ordinary pane of glass lies a fascinating story of materials science and ingenious design. In this exploration, we'll delve into the world of bulletproof glass, uncovering the secrets behind its remarkable ability to stop projectiles. From the materials that give it strength to the step-by-step manufacturing process, we'll uncover the science that makes this life-saving invention possible. Get ready to discover the magic behind this often overlooked champion of safety and security. First things first, let's clear up a common misconception. The term bulletproof glass is a bit of a misnomer. A more accurate term is bullet-resistant glass. Why the distinction? Because while this type of glass can withstand impacts from certain types of bullets, it's not entirely impervious to damage. The level of protection depends on the thickness of the glass and the type of projectile it's designed to resist. So, what exactly is bullet-resistant glass? It's a special type of glass that's engineered to be much tougher and stronger than regular glass. Imagine a sandwich with multiple layers of bread and filling. That's essentially how bullet-resistant glass is structured. It consists of layers of glass and plastic that are bonded together to create a material capable of absorbing and dispersing the energy of a bullet's impact. The key to bullet-resistant glass lies in its unique composition. Two primary materials play a crucial role: polycarbonate and polyvinyl butyrol, or PVB. Let's break down what makes each of these components so special. Polycarbonate is a type of thermoplastic. Think of it as a super tough plastic that's incredibly strong and impact resistant. It's often used in things like eyeglass lenses, safety goggles, and even DVDs. In bullet-resistant glass, polycarbonate acts as a tough outer layer, providing the initial line of defense against projectiles. PVB, on the other hand, is a type of resin that's known for its flexibility and ability to absorb energy. You might be surprised to learn that PVB is commonly used in the windshields of cars. In bullet-resistant glass, PVB layers are sandwiched between layers of glass, acting like a glue that holds everything together. But more importantly, PVB helps to absorb and dissipate the energy of a bullet, preventing it from penetrating through all the layers. Now that we know about the key ingredients, let's see how they come together to create bullet-resistant glass. The manufacturing process involves a series of carefully controlled steps that result in a material with exceptional strength and resilience. It all starts with sheets of annealed glass, which is a type of glass that's been treated to improve its strength. These glass sheets are then layered with PVB, creating a sandwich-like structure. The number of layers can vary depending on the desired level of protection. A thicker piece of glass with more layers will offer greater resistance. Once the layers are assembled, the entire structure is placed in a special oven called an autoclave. This is where the magic happens. Inside the autoclave, the glass and PVB are subjected to high heat and pressure. This process fuses the layers together, creating a single, solid piece of bullet-resistant glass. A delicate dance: heat and pressure in action. The use of heat and pressure in the autoclave is crucial to the manufacturing process. These elements work in tandem to transform the individual layers into a single unified piece of bullet-resistant glass. The heat softens the PVB, making it more pliable and allowing it to flow between the layers of glass. Think of it like melting cheese in a grilled cheese sandwich. The heat helps to create a strong bond between the bread and the cheese. Pressure is then applied to the layered structure, squeezing out any air bubbles and ensuring that the PVB completely fills the space between the glass layers. This combination of heat and pressure creates a permanent bond between the glass and PVB, resulting in a single, incredibly strong piece of material. The science of stopping a bullet: energy dissipation. The real magic of bullet-resistant glass lies in its ability to stop a bullet in its tracks. But how does it actually work? The answer lies in the concept of energy dissipation. When a bullet strikes a piece of bullet-resistant glass, the impact energy is absorbed by the layers of glass and PVB. The outermost layer of glass, while tough, will typically crack upon impact. However, this cracking is by design. It helps to dissipate the bullet's energy, preventing it from being transferred directly to the next layer. The PVB layers play a crucial role in absorbing and dispersing the remaining energy. As the bullet continues to penetrate, the PVB stretches, acting like a net that catches and slows down the projectile. The energy is distributed throughout the layers, preventing it from being concentrated in one spot. From banks to vehicles, bulletproof glass in action. Bullet-resistant glass is more than just a scientific marvel. It's a life-saving invention with a wide range of real-world applications. Its ability to provide protection from ballistic threats makes it an essential component in various settings. One of the most common places you'll find bullet-resistant glass is in banks and financial institutions. Teller windows are often equipped with this type of glass to protect employees from potential robberies. It provides a barrier that allows transactions to occur while maintaining a safe distance between customers and staff. But the use of bullet-resistant glass extends far beyond banks. It's also commonly used in government buildings, convenience stores, and even homes. In vehicles, bullet-resistant glass can be found in armored cars, military vehicles, and even some civilian vehicles where enhanced security is desired. Beyond protection, the future of bulletproof glass. As technology continues to advance, so too does the development of bullet-resistant glass. Researchers and engineers are constantly working on new materials and manufacturing techniques to create even stronger and more effective forms of protection. One area of focus is on reducing the weight and thickness of bullet-resistant glass. Traditional bullet-resistant glass can be quite heavy, which can limit its applications. New materials, such as acrylics and polyurethanes, are being explored as potential alternatives to glass, offering the potential for lighter and more flexible solutions. Another area of innovation is in the development of smart bullet-resistant glass. Imagine glass that could change its opacity or even deflect bullets using electromagnetic fields. While still in the early stages of development, these futuristic concepts highlight the potential for even more advanced and versatile forms of ballistic protection. Conclusion: the enduring importance of an invisible shield. Bullet-resistant glass is a testament to human ingenuity and our constant pursuit of safety and security. From its humble beginnings to its current state-of-the-art designs, this remarkable material has played a vital role in protecting countless lives. The science behind bullet-resistant glass is a fascinating blend of material science, engineering, and physics. By understanding the properties of materials like polycarbonate and PVB, and by harnessing the power of heat and pressure, we've been able to create a material that can withstand the immense forces of a bullet's impact. As we look to the future, it's clear that the demand for bullet-resistant glass will only continue to grow. Whether it's protecting people in banks, government buildings, or even their own homes, this invisible shield will continue to play a vital role in keeping us safe in an increasingly uncertain world. If you found this video interesting and want to discover more about how things are made, built, explored, discovered, or manufactured, be sure to give this video a comment, a like, and subscribe to Manufacta.